Presentation of engineering, graphics, and design. My name is Dr. Sammy Khoza, and my presentation is simply and design, as well as the impact that it has in the Fourth Industrial Revolution's era. This is the 5th annual Technical Teachers Conference, and I am from TUT, and I hope we are going to enjoy the presentation. So to start with, I will start by giving you the definition of what engineering, graphics, and design is. And if you're familiar with the subject, I don't think that will be too much of a challenge to you. Engineering, graphics, and design is a medium of communication through drawings, and it is a language used in industry by draftsmen to mainly uses different types of lines in order for anyone to understand it. And much as just to put it as a disclaimer, coming from a university background and training teachers, we actually don't have a challenge with the learners that are produced from school who have done EGD, especially those who come and train for the Bachelor of Education in the activity phase. So it really shows that the foundation that they actually go through and we appreciate as a university. But however, we do have a challenge in the programs that are coming from the students who are doing the same degree, but in senior primary phase. Because when they do senior primary phase, they have an option of selecting, and in technology, we do have a concept that is called graphical communication, as you all know it. And the graphical communication, it actually assists the learners to decide of a, it also assists the learners into the of engineering, graphics, and design. And in technology, when they're in senior primary phase, they do a bit of drawing. We normally find a gap because perhaps it could be that at universities that one wants to do a Bachelor of Education, we actually don't emphasize as a prerequisite. And when you start teaching them the graphical communication, it becomes an issue to them to understand it. Because I remember in the past, I was teaching, because currently I'm teaching technology, teach engineering, graphics, and design. In the past, what happened, when I started to be more serious about technology, eventually told me that they don't actually care about technology because they are going to be teaching, your other biology, could be medicine, your social sciences. So it really shows the gap that actually these students that are coming from school level, but those that come from an EGD, who are doing bachelors of education in civil or mechanical, those ones we definitely don't have a problem with when it comes to them of EGD. The only challenge is, the pedagogical part of it, when they go to teaching practice, or the didactic part, the instructional practices. Because EGD, as it stands, it shows a little bit of a gap compared to other subjects that in universities, and even at school, when we integration or fourth industrial revolutions. So in the study that I've
Hi, Dr. Khoza.
We have agreed to a statement in any technical subject, engineering, graphics, and design included, they need to have what we call spatial skill. And in the past, in the study that I've done in 2013, for us to be able to, to investigate the spatial skill in an individual, we used to have a test that we're using that was developed by a guy called Gwei in a Purdue University in the United States. But things have changed. We cannot to be stagnant. We cannot afford to continue to do things years ago, because things have with the time, hence the integration of ICT in order to be the fourth industry. But according to Elliot and Smith, in a study that they wrote in 1983, they define skill as an individual difference used in the processing of non-linguistic information. Like I said in the introduction, engineering, graphics, and design is more about lines. It's not. It's a different kind of communication that is used in industries for technicians to communicate. So, but learners or students who are engaged with this design, they have a problem in processing and linguistic information, and that shows that their spatial skill is of a certain level, which is not according to the level that we actually want. But on the other hand, says that spatial ability can be main factors. Is visualization, which is the main part that we normally find lacking in our students and in our learners when it comes to learning EGD. And the second aspect is, or the second, we call spatial orientation. And it also, there's another one, the third one, which is called the spatial relations. And all of these concepts under spatial skill are cutting across various disciplines. Why am I saying this? Is because in subjects like biology or exercises, there are studies where they do talk about the spatial skills. Where the drawings that are done, it can be perhaps when they do human anatomy, they in there, and they also have issues with spatial skill. But the main focus in our EGD, as you may all know, is the visualization. It takes time to visualize it of how drawing is being taught. As we advocate for the integration of information and communications technologies, as you will see in the that we're going to. Just read stated that most of the EGD students encounter the problem of visualization of how it, because sometimes you find that teachers are trying by all means to do the best, but the problem is they don't know how to explain some of the concepts, because EGD concepts, some of the learners themselves have not even been exposed to, they have not seen them. To some extent, you find that teachers themselves and the lecturers teaching things that they have never seen, and it becomes a challenge in order to take it down to the learners, because EGD is being taught via static, drawing or non-interactive manner, and that creates a problem. But I've seen that in recent times, the question papers for engineering, graphics and design, it shows the views, and on the side it shows the pictorial to how does this drawing look like when it is not split into two. For an example, if we talk about the orthographic projection, where it's in first angle and they show you the front view or both three views, on the right hand side, on the side, they show you the complete part as to when you look at it from this direction, drawing do we actually see, which of different to learn it, but we cannot remain on the particular level and teach it by only while we know how ICT can be used in order to enhance learning through teaching. So, the purpose of my presentation, colleagues, is emphasize in teaching and design. But I'm aware that some people believe that that's ICT integration. Well, we can debate that, but to some extent, using PowerPoint to teach might not be everything, might not assist in solving all the problems, But I think it can be a good start, because considering the resources that we have, or the resources that we don't have in our schools, we should actually appreciate
Hi, ladies and gentlemen. Apologies, it seems that we might have lost Dr. Khoza due to network connectivity. I'm just going to see if I can get him back on. If I can just ask you to please be patient with him.
And the next, the other purpose of the study is to show.
Dr. Khoza? Hi, Dr. Khoza. I'm so sorry to interrupt. Your network keeps dropping. Oh, okay. I've just dropped him. Sorry about that, ladies and gentlemen.
Okay,
Hi,
apologies.
Apologies, your network dropped. Okay, no problem. If you can share your screen again.
Okay, pleasure. Am I sharing now?
Not yet.
Not yet. Okay, let me do this. Let me do this. Let me do this.
Dr. Khoza, I'm going to ask you, if you don't mind, turning off your camera, because that does tend to help save on some internet bandwidth. So just keep your microphone on only.
Okay.
Thank you. Perfect. Now you can just click the share screen button and share your entire screen again. Okay. And then open your PowerPoint.
Is it showing?
Oh. It is. You can just open your PowerPoint, please.
Okay. All right. Okay. Apologies for that, colleagues. You know, we have a challenge of connectivity here. Industrial revolutions that we continue to face. And a view of engineering, graphics, and design, where it becomes a challenge if, for example, you look at this drawing from your right-hand side and you're expecting a student or a learner who has not been exposed to any technical experience able to understand how does this drawing scenario. Suppose you are standing or seated on the arrow that is shown where you are looking at the drawing from the right-hand side, and you expect a learner to represent that yellow block pulley there that is on the other side of the pedestal. It becomes so much of a challenge if the learner was not exposed thoroughly to the issues of line work, to the issues of line work. And then it becomes more of, now it goes back to where we're talking about when I said the issue of the concept of visualization now comes into play here, that if a learner has not seen this kind of a model before, then how do we expect to be able to navigate through the interpretation of the model itself? Then I have the second one, that is a non-written valve, which is also a typical pictorial view, where a learner is supposed to be looking at this non-written valve from their left-hand side, and they've never seen it before in their entire life, and will be able to interpret and understand what is this. So without a visual, which is part of a spatial scale, which is one of the concepts of spatial scale, we are definitely not going to win the battle of the visualization. And that is where the problem starts with now engineering, graphics, and design. We advocate for the ICT integration. So I have a typical question that is famous question that I normally use in my presentation. It is in third angle orthographic projection, as you can see that projection system symbol on the bottom right. So it is in third angle orthographic projection. It makes the top drawing or the top view or the drawing on top to be the top view, and the one at the bottom is the front view. So I will show you with the next slide how one video I got from YouTube assisted in clarifying how this is being viewed. So they're actually showing you how this web is being cut. Perhaps if I can go back, the typical exam question here is question here is that if the drawing is going to be cut here, right on the front view, in the middle of the front view, how do we then expect a learner who has never seen this kind of an object in their real life to be able to understand what is going on here? But the ICT integration that is going to be showing in the next slide is going to make that clear. But the question is, how many schools and how many institutions do they have this kind of a demonstration that will make things to be much, much? Like I said in the previous slides, we have what we call a pictorial view that is been given on a site, and this is the actual question. And since this is in third angle, this is the top view, and this is the apologies, this is the front view, and this is the top view. So the question is, draw a full sectional top view on cutting plane. Perhaps we can say the cutting plane AA. So there will be a cutting plane that has been put on the front view right in the middle and called, and we want to see how will top view look like when it is cut in full section. So the narration means that for one to see like when it is cut, you need to cut it from the front. And that is normally becoming difficult for one to explain it to another one. Even gets worse when one needs to understand that kind of a narrative. So, as you can see it, and this is one resource that can make things much, much easier. So now, for you to draw a full sectional top view, you need to cut the whole object from the front, and by using that particular the cutting object. So after doing that, what happens now? This is in third angle orthographic projection. For you to see the top view, you must look at these things from the top. So in other words, you need to imagine this top part that is being cut to be removed, and the remainder of what will be there is your top view. So this is the cutting plane, as you can see on the front view. And then from there, for you to see a full sectional top, giving a lesson now, for you to be able to see the top view, then you need to imagine the top part being removed. And then you'll be remaining with what is actually been exposed after, because the main object of sectioning is to expose the inner part of a drawing. And then this is now how it's going to look. Apologies for that. And this is now a solution of how it's going to look. But now, if I can take you back, imagine what would be going through the mind of a learner if there was no kind of technology that was showing how this was cut. So this was just going to be a nightmare. And if we can think of the mark allocation of the entire drawing of sectional, then obviously a learner stands a chance of not getting good marks or passing even the exam, if this is in the exam. So the next slide is also an example of another example where they show a rip. And you see, this is another example of a rip is to a learner who's never seen it. And then it's also in third angle. And then for you to show a full sectional right view of a rip, it needs to be cut. So you need to have a blade that demonstrates and show the learner how it is cut. When it is cut, then what happens in the mind of a learner should be visualize how is this thing going to happen. And then this should be what should go through the mind of a learner. Okay, but now that is a cutting plane on the right view that is showing red. That is a cutting plane. It is a cutting plane. But now the misinterpretation and misconceptions of could be they can section it like that. And by will simply mean that they have a misinterpretation or a misconception of how the pictorial view looks like, because now they have sectioned even everything. And we know that in EGD, much as we can cut a rip or we can cut any support that we can have in EGD, we should not show it in section, but practically we can cut it. only to find out the best solution. So section, like the way it shows on the front view, it would simply mean the entire pictorial view was this drawing shown. Conception. And we get all of these things, such challenges from the learner and the students in quite a number of situations because of not having the drawing models. But the essence of the matter now is that they have now sectioned through a RIP or through a support as it is shown. And then if they leave it like that, there's also a principal mistake because the learners will have cut or sectioned through a solid line, which is one of the main biggest principal error that one could actually commit. Only find that the final product or the final solution of a sectional front view is what it is shown there. Part of a device or of a system or of an interaction that if we can school level, even at university level, EGD will be excellently performed. We heard from the speaker yesterday, one of the district officials or the departmental officials saying EGD is not a problem. The pass mark has always been 90 or 90 something percent. The question which one can ask is, if we can go deeper to the qualitative part of the 94%, are we really that's a discussion for another day. So let me now unpack the concept of industrial revolutions. I'm not going to go too much into depth, but perhaps I can just to show you what is it that is happening with the fourth industrial revolutions, which is a concept that affects humanity. So it is a change of the use of technologies as so the fourth industrial revolution is the radical change of the use of technologies as discussed by Shaw. It deals with how technologies can enhance the solving of problems faster and better. That's in a nutshell. 3 concepts. We have the Internet of Things, we have the augmented reality, we also have the artificial intelligence. And remember, since technology is evolving every day, you might find that in the next revolutions, there could be more concepts that we can talk about, or there could be that in other countries which have fourth industrial revolutions, they come up with the fourth concept, or maybe 2 more new concepts than we actually.
Apologies, ladies and gentlemen. We seem to have lost Dr. Khoza again. If I can just ask you to please be patient while we try. Dr. Sammy, Dr. Khoza, your internet is doing again.
That's going to be used to coordinate the entire. Pardon?
Hi, sorry about that, Dr. Khoza. We are losing you again. So if I can ask you to just go back just a couple of sentences and say those last lines again.
Okay, apologies for that. Apologies. In the discussion of the Internet of Things, definition, the Internet of Things is a very broad topic that at its most basic level, it takes sensors and connectivity and apply these 2 things to everyday objects and complete systems. So an example is an inverter, which is one example that can run virtually all household appliances. Recently, when people build a house, after they install electricity, they don't connect it entirely to, let's say, for TV to work or for a freezer to work. They install an inverter, which is going to coordinate the entire current in the house so that even during load shedding, the inverter can even sustain the connectivity in the house. So it's one of the latest things that is emanating from the Internet of Things that is a basic thing that we normally have in some households, and it looks like that. Its primary function is to convert direct current power into standard alternating current. So you find a house that maybe you go to a housewarming party, no music, and you ask, but why there's no music? And they tell you, no, we're still waiting for a small device to coordinate electricity. They might be referring to this kind of a device. Or you find the athletics, you find in sports news when they report that Usain Bolt ran 9.87 seconds for 100 meters. And you ask yourself, how did they find that? There's some devices that are put on the shoe of a runner. Even in soccer, there are some small devices that they put on a soccer boot, which can actually tell how much did Cristiano Ronaldo cover in a match. And you find yourself asking questions, but how did they know that he covered 12.83 kilometers in one match? There are some devices that they put in their shoe, which has been connected to the main system where, and at times you find that some of these are more like a small vest, and in that small vest it can also coordinate or regulate one's heartbeat or one's breathing patterns. And those are the examples of the Internet of Things. Then we now have what we call another concept of 4IR, the augmented reality. This one is where you is the enhanced version of the real physical world that is achieved through the use of digital visual elements, sound, or other sensory stimuli delivered via technology. A basic example is when you go to cinemas, they normally say you can pay an extra 20 rand or an extra how much to get the 3D visuals, so that when you watch the movie, you feel like you're inside the screen. So those are some basic examples of life to be much easier and to make things to be much more enjoyable than we normally know them. Then we have the last concept of the 4IR, which is artificial intelligence, and it refers to the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. You'll see in the next slide some 3 short clips of some of the famous artificial intelligence videos that you might have come across in social media. It deals with the creation of systems that can learn to emulate human tasks using their prior experience and without any intervention. So there's this one which I think you might have a waitress who was used as a robot. Just want to share it with you. This is a robot that has been used in one of the restaurants to deliver food or food. And I know some of you might be thinking, but if we are served by a robot, then who are we going to give a tip? This is an example of a robot in the Fourth Industrial Revolution, the same as the one that we normally see on the stage of the main of the main event here in this conference. Okay, so that was an example of a waitress that was being used by a robot. So, like I said in the previous slide, the waitress is the same simulation of a human being trying to mimic what. And then here I'll be showing you the next one of a wall being built. How it happens. Okay, so I know when we started talking about the Fourth Industrial Revolutions as a country, we're talking about jobs that are going to be lost. But we need to also understand that much as we are scared of jobs being lost, there will be going to be created. Debate will be lost against those that will be created is still ongoing. Then here's the last clip that I want to share with you of a wall being. Okay, so those were the three clips that I was showing you of what the fourth industrial revolution is aiming to do. Much as we can have a debate been lost based on what we have just seen, but let's think of the duration that it took for all those kind of small jobs to be done. Here's another image of a gentleman who's carrying a radio, a video camera in front of him. There's a whole lot of these things. If you can come to imagine of this thing, all of these things now that the guy is having with him and in front of him are all in our pocket. And that is the reality of what we are faced with when we talk about the industrial revolution. You can have a cell phone that can play music. You can have a cell phone that the videos. You can actually at conference via cell phone. In fact, a couple of weeks ago, I saw a lady who was doing shopping while she was on a Microsoft Teams meeting doing shopping, because that's the kind of era that we live in. As well, or the picture there. In 2010, we had a chopper and a video, a man taking a picture. But in 2020, both these guys that we had, a pilot and a video camera, lost their job because we're now using drones. Then you can just put a camera on a drone and send it to wherever I want to go, depending on the distance that we'll be programming it to, and then it can do the job for you. So, based on discussed, ladies and gentlemen, we do have hurdles, and this is a reality. We do have challenges that we experience in the implementation of fourth industrial revolutions. Perhaps we can even talk about the challenges that we experience in EGD for ICT integration. So, if we start with, we can talk about the basic foundation, because at a very lower level, whether at early childhood level or at senior primary level, introduced. If the foundation is not going to be sound, if the foundation is not going, focused, then problem. And for one to have the best foundation or the basic foundation at the lower level, we need to have resources, which is the second challenge that we have. We need to have resources, and the resources that we have, we need to have the relevant resources, and that are, by the way, needed. Have the relevant ones. If we talk about introduction of robotics in primary school level, do we have the best resources for that? If yes, are the learners going to have that basic literacy to be able to create a robot? Because if they come to universities without the basic literacy, even when you ask them to type an assignment, it becomes a problem because they don't have the ICT literacy part of it. And if you teach a learner how to operate a computer, then how long is it going to take one to introduce them to do, things that, and all of those things. So if there was no basic foundation because of resources or because of wrong resources, surely the learner will have wrong literacy or a special skill when it comes to the learning of engineering, craft, and design. And one of the resources that we can actually talk about is the unstable electricity, unstable data. As you can see that even when I'm presenting now, I saw some of the charts that you were saying I'm breaking. So these are challenges that we experience, that much as we can have resources, we shouldn't just be bragging about the resources that are just limited. We need to have, the perfect ones, so that even when I present in a Sasol conference like this, there is no breakage of the signal, And if a student comes to the university without having proper spatial skill, they're definitely going to be a challenge. And that is why most of you guys who are teaching at school level, you often complain that some of the students that we get, we have to reteach them. There's so many issues that can be associated with that, to the so-called incomplete type of trained teachers who come and join you in schools. And all of that will affect their performance, whether at the university level or in a classroom at school level or in the teaching part of it when they now turn professional. I don't know whether there are any questions, ladies and gentlemen. Thanks, Natasha. Natasha?
Yes, I'm back. Thank you so much, Sammy, for that. I don't see any questions in the Q&A. So to all the attendees that are attending, if you're able to just load any questions that you have in the Q&A for Dr. Khoza, you can do that now, please. We'll just give it a couple of minutes, and then we'll see if anybody loads any questions. And I see something's popped up in the chat. Oh, okay. All right, Dr. Khoza, I don't see that there are any questions coming.
Okay.
So we'll just then end the session now. Ladies and gentlemen, we are going to go back to the tables, and then after this, we will be able to go into the main discussion room, and that is where we will have the feedback session. The feedback session is at 3:30. So when we go back to the tables now, you'll see on the side of your floor plan, on the side of the floor plan, it does have the buttons, and it will say click to join the main plenary. To click to join the main breakaway. And you can then just click on that, and it will take you back to the main floor. From there, you can just have a quick break, and then return at 3:30, where we'll be doing the discussion, the final discussion in that room.
Okay, now, Tasha, I see 2 questions there.
Oh, fantastic. You're welcome to answer those questions in the meantime.
Yes, I think the first one is from Tsebiso Johannes Mufukeng. Currently in our education system, EGD is not yet aligned to the fourth industrial revolutions, to be honest with you. But perhaps I might be talking from a point of view, which I might be maybe mistaken. But if I can answer you from a university point of view, we don't have the latest, technologies that can make EGD be used perfectly. But since I said that I do teach technology as well to senior primary students, our lab technicians at TUT, they are so much advanced because we do like your 3D printing, we do the laser cutting. And one of the colleagues at TUT was assisting the students to develop a cell phone stand. I know we've never seen a cell phone stand before that has been for sale in some shops, but it was a unique design which they came up with, and it works so much wonders. Perhaps the alignment of EGD to fourth industrial revolutions must cut across. We must not expect it to start only from engineering, graphics, and design only. We also need to see what is happening to other programs that the students are doing, within the same course, and see what could be the synergies between the two. But for us to align it is to enhance ICT integration to teach with it. If maybe we can adopt to what is happening to engineering drawing in mechanical engineering course, we might have an idea as to what is it that we can do to ourselves as teachers. I'm not sure if I have answered you on that, because in engineering, in mechanical engineering, they normally use a software to do it. And much as we do use a software as well in engineering teachers course, it is not as advanced as what is happening in the engineering courses, you see. And then to Mpo, thanks very much, Mpo. I think for us to share, for me to give you the good practice of how to improve learner performance in EGD, the basic way is a spatial scale, because I believe in research. We believe in research that if research says this, then we must go with research, but we should not divorce ourselves to the current challenges that we have in our schools. We should not divorce ourselves to the current challenges that we have in our universities. But if we don't have ICT resources, we don't have document cameras to, practically demonstrate thoroughly, the best way is to create models. I think it's a start. It might not be enough, but I think it's a start, because EGD is one of the abstract concepts which we teach, like things like your knuckle joint. And you find that even the teacher himself doesn't know what is a knuckle joint. And you can imagine how does that happen to a learner, where a teacher needs to explain something that is never seen. But if we can have a picture of a knuckle joint like your question papers have, where there's views as well as the pictorial views, and make the learners to create those, or have companies that we have seen them presenting in Sasol in the Sasol conferences in the past, where they say they created these models. I think that can be a start. Thanks. Thanks very much. Natasha, back to you.
Okay, wonderful. Thank you so much, Dr. Khoza, for your wonderful presentation. We are going to go back to the tables now, and you'll see on the left side, there's the strip that shows you all the breakaway names. You can just click on join the main discussion breakaway, and then you're welcome to go for a cup of coffee. Once you're in the room, you can go for a cup of coffee. You can talk to anyone that is sitting there, and just wait until the discussions start. Okay. Thank you so much.
Okay, bye.